Hello and welcome to T1 Day 11 of Honors Precalculus. Today we are going to start talking about power functions. A power function is a function of the form y equals ax to the p. Y equals ax to the p. I'll make that nice and big. Y equals ax to the p power. You need to make sure you understand that x now is in this base. It's in the base. Do not confuse this with exponential functions. Exponential functions are y equals ab to the x. X is in the power. That is not what we're dealing with here, not exponential. We're now dealing with power functions. So for example, you could have the function y equals 2x to the fifth. That's a power function. Or y equals 3x to the fourth. That's another one. You could have y equals 2x to the 3/4 power. That's a power function. Y equals negative 15x to the 1/3. That's also a power function. Anything of this form. So if we're given 2 points, how do we go about finding the equation of a power function? First, write down the general form, which is a times x to the p. To solve this, we need to find the value for a, and we need to find the value for p. Well, we have 2 points, so let's plug them in. So for 212 here, we know that 12 would therefore equal a times 2 to the p power. And for this second one right here, we would know that 48 is equal to a times 4 to the p power. We're still trying to solve for those two variables. Similar to what we've done before, we just divide. We've done similar things before where we're solving for two things. We could solve by just dividing here. So you get 12 over 48 is equal to, well, the a's cancel, and you're left with 2 to the p over 4 to the p. Oh, I got to write that properly here. Sorry, let me write that out properly for you. 4 to the p. To the p. I'm having a hard time with that. So now you have to just pull out that exponent. So what do you end up with? You can also simplify that. That right there is 1/4. And this is equal to 2 over 4 to the p power, which is 1 over 4 equals 1 over 2 to the p power right there. So what can we do in this case? Well, you have lots of different options, but you can turn 1 over 4 into 1 over 2 squared is equal to 1 over 2 to the p. It's the quickest way I know how to solve this without going into logs and things. But if 1/2 squared is equal to 1/2 to the p, therefore we know that 2 is equal to p. That's kind of helpful. So now that tells us that we have y is equal to a times x to the second power. So now we need to solve for a. How do we do that? Well, we pick either one of the points. Let's say 212 was one of the points, and we just plug it in to make it true. So you take 212 and you plug it in. So 12 is equal to a times 2 squared. So that means 12 is equal to a times 4. So a is equal to 3. So our final answer to this one, would be, now that we know that a is equal to 3, and we know that p is equal to 2, our final answer would be y equals 3x squared. That would be our final answer. You can do the exact same thing right here. You plug in the 2 and then divide. Plug in the 2 points and then divide. And if you divide these, you end up with 27 equals 3 to the p. And that is just going to be 3, which tells you y is equal to ax cubed. And then you plug in, let's say, this nice point right there. The other one's fine. Either one will work. But that tells us that 5 is equal to a times negative 1 cubed. So a has to be negative 5. Therefore, our final answer would be y equals negative 5x cubed. So plug the points in, solve the simultaneous equations. So this one says graph each of the following, then find all of the intercepts exactly. Now if you had a calculator, you could just plug this in and do it exactly as it stands. But if we wanted to translate this, we could translate it by starting with the root graph, like the base graph, and that would be x to the 4th. And then translate y equals x to the 4th. So we have a regular parabola right here. X to the 4th is just going to be steeper. It's going to be a lot steeper. So for example, you can make a table and plug in some smaller values. You know it's going to go through the origin, and when x is 1, 1 to the 4th is 1, 2 to the 4th is 16. So this one's going to look like this. It's going to be pretty steep. It'll be 216 right there, and 1, 1 there. And then if you plug in negative 1 and positive 1 into this, negative 1 and positive 1 into this, you would get the same thing but to the left. So it's going to be negative 1, 1, and over here, negative 216. What do these things do here? This negative 1 here moves it left 1, and then this 6 right here moves it up 6. And then what does, you might remember, what does this negative 2 do? It flips down and stretches vertically by 2. So what does that mean? It means the origin is going to go left 1 and up 6. So the origin, like the little, I'll say the origin, but the vertex, the vertex, left 1 and up 6 to here, and then it's going to go down and be twice as steep. So instead of going over 1 and up 1, it'll go over 1 and down 2. So it'll be here and here. And then you can double everything else and make it steep. So the exact graph will look like this. It'll be pretty steep. That curve is a little tough. And then it says find all of the intercepts exactly. How do we do that? Well, the x-intercept is when y is 0. So that's when 0 is equal to negative 2x plus 1 to the 4th plus 6. So that's negative 6 is equal to negative 2 times x plus 1 to the 4th. So that's 3 is equal to x plus 1 to the 4th. To get rid of a 4th power, you need to take the 4th root. So it's going to be plus or minus the 4th root of 3. That 4 has to be tinier and up to the left, and that will equal x plus 1. So x is going to be negative 1 plus or minus the 4th root of 3. It's very important you write that 4 tiny and up like right there. If you wanted the decimal, you'd have to use the calculator for this. But what does this mean? This point right there, the x value is equal to negative 1 minus the 4th root of 3. And this x value right there is negative 1 plus the 4th root of 3. That's where those intercepts are. Now, the y-intercept, it's already on there, but the y-intercept is when x is equal to 0. You just plug in 0 for x, and that's going to be negative 2 times 0 plus 1 to the 4th plus 6. Well, that's negative 2 plus 6, which is 4, which does match what we have there of 0, 4. So how do we do that for this one? Well, we start with the base graph, and it's to the 5th power, so it's going to look like q, but steeper. It's going to go up like this. And then what does this negative 2 do right here? That means it's 2 right. And then what is this going to do? This 1, that 1 is going to go up 1. So this vertex right here, we know it's going to go 2 to the right, and it's going to go up 1. And the original vertex is 0, 0. So we know where the vertex is going to be. And then you can just plot points. To do that. It's going to be a little fraction. It's going to be a little challenging, but instead of the graph starting at the origin, we know it's going to start at over 2 up 1. It's going to start right here. And it's going to vaguely look like an S, like this. So if we want to know exactly what it looks like, let's plot at least one other point. So one thing you can do is you could plug in 2, just to get a nice answer here. Well, that would be sorry, if you plug in 2, that would be the actual point we're at right there. So if you plug in 3, for example, if you plug in 3, g of 3, you'd end up with 1/8 times 3 minus 2 to the 5th plus 1. This is nice because 3 minus 2 is 1, 1 to the 5th is 1. This is just 1/8 plus 1. So what does that mean? When you're at 3, it's just a little bit higher. So that means it's going to be symmetric around that point. So the other one is going to be, for example, g of 1 would be 1/8 1 minus 2 to the 5th plus 1. Well, that's going to be 1/8 times negative 1 to the 5th, which is negative 1. So that's going to be 1 minus an 1/8, which is 7/8. So that's back down a little bit too. So what is this going to look like? Well, it's going to look like this, and then it'll curve up like that. And if we wanted to know the exact intercepts, we'd have to find them by plugging in 0. So if we want the y-intercept, that's when x is equal to 0. So that's g of 0 is equal to 1/8 times 0 minus 2 to the 5th plus 1. So that's going to be 1/8 negative 2 to the 5th plus 1. Negative 2 to the 5th is negative 2 times itself 5 times. So that's 2, 4, 8, 16, 32. negative 32 over 8 plus 1. So negative 4 plus 1 is negative 3. So the y-intercept is actually 0, negative 3. So if we graph this, what it means is we thought it kind of looked like this, but it's actually going to be a little steeper because it's going to cross right at negative 3. So it's going to be right like this. And then the other side will do the exact same thing, but a little higher. So it's going to go like that. Oh, that's not very smooth, is it? So it's going to go up like that. Yay. What about the x-intercept? We need to find this x-intercept right about there. That's where we've graphed it so far. What is that? The x-intercept is when y is equal to 0. So 0 is equal to 1/8 x minus 2 to the 5th plus 1. Now we need to solve for x. So we have negative 1 equals 1/8 x minus 2 to the 5th. Multiply both sides by 8. Negative 8 is equal to x minus 2 to the 5th. Take the 5th root. You are allowed to take the 5th root of a negative number because it's an odd root. So it's not plus or minus. It'll just be the 5th root of negative 8, which will be negative, equals x minus 2. So then what do you end up with? Well, sorry, you can say plus or minus, excuse me. Sorry, it's just plus. Just plus, sorry. So then you add 2 to both sides, and you get x is equal to 2 plus the 5th root of negative 8. And the reason it's just plus is because this will come out to be negative. There's only one 5th root of 8, negative 8. There's only one 5th root of any number. It's an odd root. There's one answer. So if you plug this into their calculator, you'll get the x value right there. You can't do 5th roots by hand. If you want more practice, definitely do this one on your own. It's pretty fun. The next topic inside this one is the idea of proportionality. First one is y is directly proportional to x if y is equal to k times x, where k is a constant of proportionality, and y is inversely proportional to x if y equals k over x, where k is the constant of proportionality. So this is just two ways of expressing proportionality that we will use. So for example, suppose y varies directly with x. If y equals 30 when x equals 6, find the constant of proportionality. Since it's directly, we know it's y is equal to kx, and we know that when y is equal to 30, we know that x is equal to 6. So 30 is equal to k times 6, so that means that k has to be 5, which is our constant of proportionality. So our function would be y is equal to 5 times x. And then it says, use your formula to find x when y is 10. So that's 10 is equal to 5x, so x is equal to 2. So there is your formula. There's your constant of proportionality, and when y is equal to 10, x is equal to 2. What about inversely proportional? Inversely, so y is equal to k over x. And when y is equal to 5, x is equal to 2. So that means 5 is equal to k over, excuse me, not k. 5 is equal to k over 2. So k is equal to 10. So that means our function is going to be, that you can relate, is y is equal to 10 over x. And then it says use your formula to find y when x is equal to 20. So when x is equal to 20, y is equal to 10 over 20. That's where you put the 20, that equals to 1/2. So when we have the second part of that. These two examples are relatively straightforward. They will get much more fun.